try another example to integrate the functions by using the partial fractions. This is the functions that you need to integrate. The function here seems to be quite complicated, and they appear in the divisions or fractions conditions. Under these circumstances, integrating by using partial fractions will be more appropriate. And there are boundary conditions here. That means we are talking about definite integral. To solve this, first we look at the power here. The power here is larger than this. That means there is a possibility of divisions of the two terms. Put the upper function here and the lower function here. The largest power is power 3, and the largest power here is power 2. In order to obtain power of 3, you will have to multiply with x. With that, the entire function here is to be multiplied with x. That gives you this. Every single term here will be upgraded by one level of x. Minus the upper functions with the lower functions. The x3 here are cancelled out. Negative 2 minus 1 will give you negative 3. Negative 4 plus 2 will give you negative 2. The negative 4 here will be brought forward since here is 0. This is the leftover of the divisions. Look at the term here. They are at the same level. That means you can do another kind of divisions. The first term here is negative 3x squared. In order to cancel out the term here, you will have to multiply this x squared with negative 3. With that, the entire function here is to be multiplied with negative 3 in order to produce this. Minus these functions with these functions, the x3 are being cancelled out. Minus 2 plus 3, you will get x. Minus 4 minus 6, you will get negative 10. At this stage, the power here is less than this. That means you will stop the divisions here. This will be the remaining. With that, these functions can be rewritten in the terms of x minus 3 as obtained here, and the remaining divided by this x squared plus x minus 2. Factorize the function here. You get x plus 2, x minus 1. You can do partial fractions for this. Equate this with two partial fractions of the constant a and b here, where the factors will carry individual partial fractions. Multiply a with the factors of the other partial fractions and multiply b with the other partial fractions. Expand this and rearrange it in terms of the x and the constants. Compare the function here with this. You know that a plus b will be equals to 1. A minus 2b will be equals to 10, since the negative value is the same. That gives you two equations with two unknowns. Solve the equation simultaneously. You get a equals to 4, b equals to 3. With that, you are able to integrate this. Based on the division's outcome here, you know that this one will be equals to this. And based on the partial fraction calculation here, you know that this will be equals to this, where your A and B is being substituted. That gives you this. Now you can integrate them term by term. Integrate the first term, second term, third term, and the fourth term. And remember the boundary conditions. Substitute the upper boundary into the functions, minus with the substitutions to the lower boundary. Then you will get your final answer as negative 1.687. Let us try another example. This is the questions that you need to integrate. It is in the square in terms of the factors. Expand this in terms of the partial fractions. It will be power 1 and power 2 of the factors. To have this having the same factor below, you will need to multiply again with this so that you get square here. So A is to be multiplied with x minus 2. Expand it and classify them into an x and the constants. Compare them with the function here. You know that A is equals to 2. Minus 2A plus B will be equals to 3. Solve the two equations simultaneously, you get A and B. Substitute this A and B into the equations. You know that integrations of this will be equals to integrations of this. Then you can integrate the two equations separately. However, you see there is a functions within function here. So you will use this as a u, and then du will be equals to dx. Convert this in the form of u and du. It is given that the dx is equals to du. You can change the dx directly into du in this case. This gives you 7 divided by u squared, which is 7 multiply u power of negative 2. Integrate it. The power here is to be plus 1, and the new power here will be the divisions. Rearrange it. Substitute back the u from here. Then you will get the integrations. With that, you integrate the first term, you get long, and integrate the second term, you get the answer here. Remember to put a constant c at the end of the expressions. Let us try this example. This one consists of 3 factors in fact. That means you have to expand it into 3 partial fractions. This is the first factor. X minus 1 to be power of 1 and x minus 1 to be power of 2. Then for the A, multiply x minus 1 square. For the B, multiply x plus 3 and x power 1. And for the C, multiply with x plus 3. That gives you this. So that they are having the same factors below the fractions. Expand the functions. Substitute the value into the functions. Rearrange it in terms of x squared, x and the constant number. Then compare this with the equation here. you will see a plus b will be equals to 5. Negative 2a plus 2b plus c will be equals to 2. A plus 3b plus 3c will be equals to minus 19. You have 3 equations with 3 unknowns. Solve the equations simultaneously. You get a, b, c equals to 2, 3 and negative 4 respectively. Now you rewrite these functions in the form of partial fractions. You will see here is the factor in the power of 2. There is a function within the function. With that, you can use this as a u here. Differentiate it to get du equals to dx. Substitute this with the u. You get 4 divided by u squared. And convert this dx based on du equals to dx. You will get du here. Rewrite it in the terms of u power negative 2. Integrate this. You get this. Substitute back the u into the equations. Remember the c. Now you integrate the functions term by term. Integrations of the first term, second term, and the third term. The integrations of the third term is obtained from the calculation step earlier on. Remember to incorporate the constant c here. Move the 2 to become square and the 3 to become cubic to the factors. The relationship is in the plus mode. That means they are in the mode of multiplications. Rewrite the equations, you get the final answer. Let us try another example. The factor here is in the power of 3. That means you are expecting 3 partial fractions. Power of 1, 2, and 3. There will be a, b, and c to be computed from the numbers here. To have this equate to this, you will have to multiply this with a square and this with a power of 1, and this shall remain. That gives you this. Expand this and classify them according to the x squared, x, and the constant. Make direct comparison with the function here. You know that a is equals to 3, 6a plus b equals to 16, 9a plus 3b plus c equals to 15. You have 3 unknowns and 3 equations. Solve them simultaneously, you get a, b, and c. Substitute this value into the function here. That means integrating this is actually equals to integrations of this. You may integrate them term by term. And what you see here is there are functions within functions. With that, you need to follow the calculation step which we have discussed in the previous examples. With that, the integrations of the second term will give you this, and the integration of the third term will give you this. There is a boundary there. That means this will be the definite integral. Write down the boundaries. Substitute the upper boundary into the functions to be minus with the substitutions of the lower boundary in the functions. Your final solutions will be this.